This video is going to be about using trigonometry to solve for a missing angle in a right triangle. Up until now, we've been solving for missing sides when we know an angle, but we'll see how to use trigonometry and the calculator to solve for a missing angle. Let's start with a quick definition of theta. It's a Greek letter that stands for a missing angle. It's sort of like the way we use x to stand for a missing side. We write theta with a circle or more of an ellipse, an oval with a line through it. And all it is a variable representing an angle. Write down this definition on your note sheet. Below the definition of theta on your note sheet, look at example 1. I've redrawn it here. Let's go through and see how to solve example 1. Please be sure to copy this down onto your note sheet. I'm going to start this problem in the same way I used to start all my other problems, by labeling my opposite, adjacent, and hypotenuse side. This time I'm going to use angle B as my reference angle because I know that's the angle I'm solving for. I know this because the theta is sitting in angle B. So I know 16 is my hypotenuse. BC, which has nothing on it, is my adjacent. And then AC, the 7, is my opposite side. Looking at this and knowing SOHCAHTOA, I know I'm going to use sine. That's because I know both my opposite and my hypotenuse. I don't know anything about my adjacent side, so using one of the ratios that uses the adjacent side wouldn't really help me. So now I know I'm going to use sine. So I'll say sine of theta, because I don't know what it is, so I'm just going to leave the theta, equals 7 over 16. Now I know it's super tempting to want to go straight to the calculator and hit sine 7 over 16, but don't. Think carefully about what this fraction represents. These are sides. Whenever we write sine parentheses and then we put something in here, that has to be an angle. You cannot put sides inside the sine. So when you have sides, never put them inside the sine. Instead, we're going to use something called the inverse sine. It looks like this, sine -1. And we can put our 7 over 16 into that. Let me quickly recap that. The sine function takes an angle and gives you a decimal that represents the side ratio. The inverse sine does the opposite. It takes the side ratio as input and spits out an angle. So you can always decide which you're using by what you're trying to find. If you want an angle, well, you're going to use the inverse sine. If you want a side, you're going to use the regular sine. Let's do example 2 now. Please make sure you write this on your paper. So again, I'm going to start labeling my sides based on, again, I have angle B with the theta. So I know AB is the hypotenuse because it's the longest side. 16's opposite, and BC is adjacent. So I notice that I have an opposite and an adjacent, and I don't know my hypotenuse. So I'm going to use tangent because of TOA. So I'll say tangent of theta equals 16 over 5. So I now know, since I'm looking for the angle, I'm going to use the inverse, and so I'll put 16 over 5 in my inverse tangent, and that will give me the angle. Now I'm not going to show you the calculator again, but I hit second, tan, and then 16 divided by 5, and then I close my parentheses. The parentheses were actually opened right here, but they did that for you. So this is my calculator. and it's going to give me 72.6 degrees. Now, depending on the calculator you use, you might have a different set of buttons to push. So, for example, on the computer, if you're using the computer calculator, you have to press a button that says INV, and then you'll press sign. So you'll really just need to experiment with any of your individual calculators. To finish your homework, I'd like you to do example 3 and example 4 on the front side of the notes sheet. And if you're struggling to find the inverse, sine, cosine, and tangent on your calculator, please feel free to send me a Schoology message or an email. Thanks. Good luck.